Hi, I'm Ms. Kissel, and I'm going to review velocity, acceleration, and free fall. First, I want to talk about the difference between speed and velocity. Speed tells you how fast you're going. It's calculated by dividing the distance by the time. For example, speed might be in miles per hour, meters per second, or centimeters per year. Velocity is the same as speed, except velocity also includes direction. So we just say velocity is speed with direction. For example, if a car is driving 40 miles per hour north, its speed is 40 miles per hour and its velocity is 40 miles per hour north. Notice the letter V is used here to represent speed in the formula. It's because velocity is calculated the same way as speed. Now I want to talk about acceleration. Acceleration tells you how quickly velocity changes. Acceleration is calculated by finding the change in velocity. The triangle, or the Greek letter delta, is used to represent change. So change in velocity divided by the time. So if an object is moving at a steady speed, a constant velocity, then it does not have any acceleration. If an object is speeding up, we say it has a positive acceleration. If it's slowing down, it has a negative acceleration. Objects can also accelerate if they're moving at a steady speed but are changing direction. So a car driving at 20 miles per hour around a bend is accelerating because its direction is changing. This is not really the formula we would use to calculate that kind of acceleration. That's something that we'll talk about in Chapter 9. Free fall is a special kind of acceleration. When an object accelerates on Earth's surface, the acceleration, which is the letter G, is 9.8 meters per second squared. The square means meters per second per second. So the acceleration is really 9.8 meters per second, meaning that every second the object is falling, the speed increases by 9.8 meters per second. To make things simpler, we'll be using 10 meters per second. If I drop an object, it starts out at a speed of 0. 1 second later, it has a speed of 10 meters per second. Another second later, the speed is 20. Another second later, the speed is 30, and so on. An easy way to calculate the speed is just to multiply the time by g, 9.8 or 10. So for example, if an object were falling for 4.5 seconds, the speed would be 4.5 times 10, or 45 meters per second. Now we've only been talking about objects that are dropped, but what if you throw something upward? Suppose I throw something up at a speed of 50 meters per second. No, Oliver, I can't play with you now. If it's being thrown up at 50 meters per second, then 1 second later it will be going 40 meters per second. It will lose speed on the way up at the same rate it gains speed on the way down. The next second it will be going 30, 20, 10, and then 0 at the top. Once it reaches a speed of 0 at the top, it starts to fall back down, Oliver, and it speeds up until it hits the ground going 50 meters per second. Free fall distance is not calculated using the simple speed equals distance divided by time formula rearranged for distance. This is because an object's speed is constantly changing when it's in free fall. Instead, we have to use the free fall distance formula, which says distance is 1/2 gt squared, or distance is 1/2 times acceleration times time squared, because the acceleration is g. Let's do an example of this kind of problem. Suppose I drop something and it falls for 2 seconds. What distance does it fall? Well, I just say distance is 1/2 times 10 times 2 squared. Half of 10 is 5, and 2 squared is 4, which means it's going to have fallen 20 meters. Now I have some practice problems for you to try. Pause the computer and write down your answer on paper. All right, let's figure this one out. Distance is 4,000 meters and the time is 2 minutes, but we want the speed in meters per second. So we have to do speed, distance over time, 4,000 meters divided by 120 seconds, because there are 120 seconds in 2 minutes. And if I get my calculator out, I find out that it's going 33.3 meters per second. Try problem 2, pause the video and start it when you're ready to check your answer. All right, let's see, the car starts out and it has a speed of 0. I'm going to make a table to figure this out, and then I'll figure it out mathematically. So for my table, I'm going to put time in seconds and speed in meters per second. So at time of 0, the speed is 0. If the acceleration is 2 meters per second squared, that means the speed increases by 2 meters per second every second. So at 1 second, the speed is 2. At 2 seconds, the speed is 4. At 3 seconds, the speed is 6. I'm running out of space here. At 4 seconds, the speed is 8. And at 5 seconds, the speed would be 10 meters per second. So the answer is 10 meters per second. We can also figure this out using the acceleration formula. So it started out at a speed of 0. It accelerated at 2 meters per second squared for 5 seconds. Acceleration is change in speed divided by time. So we have 2 equals change in speed divided by time. If I multiply both sides by 5, I get 10 equals change in speed. That means the speed increases by 10 meters per second. It started out at a speed of 0. It sped up by 10 meters per second, so the final speed is 10 meters per second. If it had been moving some speed at the beginning, we would have had to add that speed to our 10, because the 10 meters per second is just how much the speed increased. Try number 3. Let's see, how much does the car's speed change? Well, it started out at a speed of 12, and now it has a speed of 18. So the car's speed increased by 6 meters per second. Acceleration is change in speed divided by time, or 6 divided by 10, or 6/10 of a meter per second squared. So the speed increases by 0.6 meters per second every second. Try number 4. We can do this using the formula, or we could also do this one with the table. First, I'll do it with the table. Let's see, it starts out, it's going 100 meters per second. So at time 0, the speed is 100 meters per second. The acceleration is 5, so we want to figure out how many seconds it'll take to get to 125. At 1 second, the speed would be 105. At 2 seconds, the speed would be 110. At 3 seconds, the speed is 115. At 4 seconds, the speed is 120. And at 5 seconds, the speed is 125 meters per second. So it takes 5 seconds. If I want to do this using the formula, I can say acceleration equals change in speed over time. 5 equals change in speed divided by time. Well, let's see, change in speed. It started out at 100. It's speeding up to 125. So the change in speed is 25. 5 equals 25 divided by what? You can solve this by cross multiplying or just do it in your head, and you see that time is 5 seconds. Try number 5. If it falls for 4 seconds, that means it's going to start out at 0, then it's going 10 meters per second, 20, 30, and finally 40 meters per second after 4 seconds. To find the distance, we have to use distance is 1/2 gt squared, 1/2 times 10 times 4 squared, or 5 times 16, which is 80 meters. Try number 6. This time we're throwing a ball upward. How many seconds does it take to get to its high point? Well, let's see. I'll draw a picture. It starts out, it's going 30 meters per second at time 0. 1 second later, the speed is going to be 20 meters per second. The next second, it's going to be 10. Running out of space here. And finally, another second later, the speed is 0. So this is time 0, so it takes 1, 2, 3 seconds to get to the top. Don't make the mistake of calling this 4 seconds because this is time 0. You have to count the steps between 1, 2, 3. So it takes 3 seconds to get to the top. How fast is it going 2 seconds after it leaves your hand? Well, it loses 10 meters per second each second, so it's going to lose 20 meters per second. Or we can look at our picture and see, well, this is 0 seconds, 1 second later it's going 20, 1 second later it's going 10, so the speed is 10 meters per second. And how much time does it spend in the air? Well, if the speed is 30, it's going to take 3 seconds to go up, and then 3 seconds to go back down. So the total is 6 seconds in the air. Try number 7. We're looking for a distance here, and we know the time is 3 seconds. So we just do distance is 1/2 times gt squared, or 1/2 times 10 times 3 squared. 5 times 9 is 45 meters. Guess what? You are done.